Hey everyone! What if I told you that waiting hours for your phone to charge could become a thing of the past? I mean, completely gone. Today, we're diving deep into a patent for a technology that could totally flip the script on how we use energy. Let's get right into it.
Okay, let's be real for a second. We've all been there, right? Your phone battery is a champ. It lasts all day. But the second it dies, you're stuck, chained to a wall outlet for what feels like an eternity. Why is that? It seems like a simple question, but it gets to the very heart of a huge challenge in energy storage.
Well, it all boils down to this classic trade-off. Think of your phone's battery, a lithium-ion battery, as a marathon runner. It's got incredible stamina, right? It can store a ton of energy to get you through the day. But it releases that energy kind of slowly, and it takes a long time to refuel. On the flip side, you have a traditional supercapacitor. This thing is a sprinter. It can give you a massive burst of power, like instantly, but its tank is tiny. It runs out of juice almost as fast as it delivers it. So you're forced to choose. Do you want endurance or do you want speed? You can't have both.
But what if you didn't have to choose? What if we could create a new kind of energy athlete? One with the long-lasting endurance of a marathon runner and the explosive, instant speed of a sprinter. That's the Holy Grail, and that's exactly the problem a team of inventors decided to tackle. And that brings us to the star of today's show, U.S. Patent 2022/0246363A1. This document lays out the blueprint for a hybrid supercapacitor, something designed from the ground up to combine the very best of both of those worlds.
So what in the world is a lithium-ion hybrid supercapacitor? It sounds complicated, I know, but the idea is actually super elegant. Imagine a device that's two-faced, but in a good way. One side is built like a battery, designed to hold a whole lot of energy. The other side is built like a capacitor, designed to unleash that energy in the blink of an eye. It's a true hybrid.
And hey, don't just take my word for it. The inventors say it themselves, right there in the patent. They state that their invention, quote, advantageously combines the functionality of a battery-type electrode and a supercapacitor-type electrode. In plain English, that means you get the high energy storage of a battery plus the insane power and crazy long lifespan of a supercapacitor, the whole shebang.
So how on earth did they pull this off? What's the secret sauce? Well, the magic isn't just one thing, it's two. It all comes down to two custom-designed nanomaterials, one for each side of the device. These are the secret ingredients, so let's break them down.
First up, let's talk about the anode. This is the marathon runner side, the part that's all about storing energy. It's made of an incredible material called nitrogen-doped carbon nanotubes. Let's just call them NCNTs for short. Okay, so what makes these NCNTs so special? Well, for starters, they're like millions of microscopic, hollow straws, which gives them a massive surface area to pack energy into. But here's the really clever part. The inventors used a process called doping, where they weave nitrogen atoms into the carbon structure. This creates these tiny little imperfections. Think of them like perfect little docking ports that are extra sticky for lithium ions. This lets the material grab onto and store way more energy and move it around faster. Oh, and as a cool little bonus, some sulfur gets mixed in during the process, which pries the structure open just a tiny bit more, making even more room for energy.
And get this, the way they make this stuff is wild. They mix two chemicals for only 20 seconds. That's it. Then they just leave it alone for 12 hours. And during that time, these complex nanotubes literally build themselves. After that, they just bake them at a super high temperature for another 12 hours, and poof, you've got this incredible high-performance nanomaterial.
All right, so that's the anode, our marathon runner. But what about the sprinter? For the other side of the device, the cathode, the inventors turned to a material you've probably heard of, a true superstar of the nano world, graphene.
Graphene is basically the perfect material for this job. You can think of it as an electrical superhighway. It's ridiculously conductive and has a huge surface area, creating this perfect, low-friction network for ions to zip in and out of at incredible speeds. This is what gives the device its lightning-fast charge and discharge capability.
Okay, the science is cool, the materials are cutting edge, but does it actually work? This is where things get really, really exciting. The inventors published their test results right in the patent, and let me tell you, the numbers are staggering. Let's look at the proof.
First up, lifespan. They put this device through 4,000 complete charge and discharge cycles. Now, to put that into perspective, the battery in your smartphone starts to feel pretty tired after maybe 500 cycles, 1,000 if you're lucky. We're talking 4,000.
And after all that punishment,
After 4,000 cycles of being filled up and drained completely, it still held on to 92% of its original energy capacity. That's not just an improvement, that's a whole different league. This thing is built to last, period.
So, the big question, did they solve the marathon versus sprinter problem? This chart is a giant, flashing yes. Look at this. They achieved an energy density of 257. That's the marathon runner's endurance, which is amazing for a device this fast. But they also delivered a power density of 468. That's the sprinter's explosive speed. As you can see, it just blows these other advanced technologies out of the water. They actually did it. They built an athlete that can do both.
The performance is just off the charts. But let's bring this all back down to earth for a second. Why does this matter? What does a future powered by this kind of technology actually look like?
Well, the possibilities are huge. Seriously, think about electric cars that could recharge in minutes instead of hours, or city buses that get a full power boost in the few seconds they stop to pick up passengers. It could even help make our power grids more stable and efficient. And yes, of course, this could finally give us phones, laptops, and all our other gadgets that charge up in the time it takes to pour a cup of coffee.
And all of this leads us to one final, mind-bending question. We have designed so much of our modern world around the limitation of charging time. We're used to waiting. If that limitation just vanishes, if charging becomes essentially instant, what new doors does that open? What will we be able to invent next?